So we end up with a solubility of 1.0 times 10 to the negative 9, which says which one's more soluble? Silver chloride or silver bromide? Silver bromide. Whereas in the previous examples, it was the silver chloride that was more soluble. And so having the presence of common ion will impact the solubility. How the solid splits up will impact the solubility. And the magnitude of the K will impact the solubility. And so normally when we're thinking about solubilities, we actually do a calculation. So what we're going to do here is we're going to look at this fractional precipitation. And so what a fractional precipitation is we're going to try to separate the ions. So I have chloride and bromide ion in here. And what I want to do is I want to add the silver and precipitate one, but leave the other in solution. So what I'll do is I'm going to do a slow addition of silver ion. And the first question that comes up is which precipitates first? Normally you would automatically think that the one with the smaller KSP precipitates first, right? But that's not the case because it depends on how the ions split apart and what the initial concentrations are. And so in order to figure out which precipitates first, we have to do a calculation. If this were 0.100 molar and 0.100 molar of these two each, then silver bromide should precipitate first because it's less soluble. But if I make these different concentrations, let's say I make the chloride 0.0500 molar and the bromide 0.250 molar. Then this would be pretty obvious. Which one would precipitate first? This one would be pretty obvious because one, silver chloride and silver bromide split in the same way. That is, they both split up into two ions. So the splitting is the same. And two, in pure water, bromide is less soluble. So if we have a lot of bromide present, a lot of common ion, that's going to make it even less soluble. And so in this case, bromide for sure will precipitate out first, right? Because not only does bromide have a smaller KSP, it's got a lot of common ion there. And so bromide would precipitate first. But what if I had this? What if I reversed them and put 0.250 molar here and 0.0500 molar here? Is it really so clear which one precipitates first now? On the one hand, bromide has a smaller KSP, and therefore it's less soluble. But on the other hand, we have less common ion. Less common ion makes it more soluble than more common ion. The more common ion we have, the less soluble it becomes, right? And so this one is really a question mark. I don't know which one precipitates first. And so in general, you know, you can't just see it right off. Then what we'll do is we'll just do a calculation. Which one precipitates first? And so what we're going to do is we're going to do a slow addition of the silver ion. What the slow addition means is initially the concentration is very low. And so at the beginning, the silver ion concentration is very small. Therefore, when we look at it, QSP for silver chloride will be less than KSP. And QSP for silver bromide will be less than the KSP. It will be for silver chloride, for silver bromide. And QSP is just the initial silver ion concentration times the bromide concentration, or initial silver ion concentration times the chloride ion concentration. And so if these two numbers are very small, then nothing's going to precipitate. In other words, it's unsaturated. All right, then what we're going to do is we're going to calculate the concentration of silver ion required to saturate the solution. Okay, to saturate in terms of silver chloride. In order to saturate the solution, then QSP has to equal KSP. And that means that the silver ion concentration times the chloride ion concentration has to equal 1.8 times 10 to the minus 10. Then we know it's saturated. And so that means the silver ion concentration required to fulfill this is going to be 1.8 times 10 to the minus 10 divided by the chloride ion concentration. The chloride ion concentration that we picked was .0500? Is that right? Yeah, okay. That means with a chloride ion concentration of 0.0500, how much silver is required to saturate it? At 3.6 times 10 to the negative 9 molar. All right, so we call this a saturated solution. If the silver were here, if the silver were less than this concentration, we call it unsaturated, so more silver can be added without anything happening. If the silver ion concentration were greater than this, let's say I try to make it greater. If I try to make it greater, then Q is going to be greater than K, right? Because the silver is going to be too big. And so if it's greater than this, we call it supersaturated. And if it's supersaturated, that means we're going to get precipitation occur. And so at concentrations greater than 3.6 times 10 to the minus 9 molar, silver chloride should precipitate from solution. We repeat this calculation for silver bromide, and then just see. For silver bromide, we know a saturated solution is going to have a silver ion concentration times a bromide ion concentration equal to 5.0 times 10 to the minus 13. Well, we already know what the bromide is because it's fixed in this problem. The silver is adjustable. And so this is going to be 5.0 times 10 to the minus 13 divided by the bromide, which we picked as 0.250 molar, correct? And this means that the silver ion concentration must be what? 2 point what?
2.0 times 10 to the
negative 12 molar. And so if the silver ion concentration equals that, then we call it a saturated solution. Saturated solution, it shouldn't precipitate until it exceeds that. If it's less than that, it's unsaturated, and so we aren't going to get any precipitate. So for these first two, there's no precipitation. It's just when we exceed a concentration of 2.0 times 10 to the minus 12, then it becomes supersaturated, and we're going to get a precipitate result. you can see, because of their different solubilities, they're going to require different amounts of silver for saturation and precipitation. And so here, for silver chloride, we're going to need 10 to the minus 9 molar to saturate, and greater than that to precipitate. For bromide, we're going to need 10 to the minus 12 molar. And so if we're adding silver ion very slowly, so that the concentration increases, then what's going to happen is this. So we continue the slow addition of silver ion until we get to a silver ion concentration of what? Well, as the silver ion concentration increases from 0 on up, the first point we're going to hit is 2.0 times 10 to the minus 12 molar. When the silver ion concentration gets to 2.0 times 10 to the minus 12 molar, then silver bromide is saturated. Okay, so the scenario here is, in this beaker, nothing's precipitated out, but we have chloride, we have bromide, and we have silver ion. The chloride is 0.0500 molar. The bromide is, was it right? No, 0.250. Shoot, did I get it mixed up from the original problem? The original setup, did I have it 0.250 chloride or 0.250 bromide? Bromide? All right. I didn't want it that way, but it's okay. 0.250 bromide, and then the silver ion concentration is 2.0 times 10 to the minus 12 molar. And so what does this mean? This means that the combination of silver chloride, this is unsaturated because QSP is less than KSP. Nothing's going to happen between silver and chloride. Right? QSP is less than KSP. But for the combination between silver and bromide, it's a different story because silver and bromide form a saturated solution. That is, QSP is equal to KSP. And so this solution is saturated in silver bromide, but unsaturated in silver chloride. Well, if I have a saturated solution and I try to add more silver, what's going to happen? If I have a saturated solution and I try to add more silver, then it's going to precipitate. And so I'll continue the addition. And so I'm going to increase the silver ion concentration from here. And silver bromide begins to precipitate. But silver chloride won't precipitate. Silver chloride stays in solution until I keep increasing it, and then I need to stop at a silver concentration equal to, what was the silver concentration required for the silver chloride? .6 times 10 to the negative 9 molar. I need to stop here because what's going to happen is the more silver I add You know, as the silver concentration goes up, the bromide concentration has to go down. And so the more silver I add, the more bromide I precipitate out of the solution. In order to precipitate out all the bromide, I'd have to add an infinite amount of silver, but I can't. You know, that's impossible, number one. And number two, I don't want to go past 3.6 times 10 to the minus 9 molar. Because what happens when I hit a concentration of 3.6 times 10 to the minus 9 molar? Yeah, then it becomes saturated in both. And so what I'm going to have here is, I'm going to have chloride, I'm going to have bromide, and I'm going to have silver. And then on the bottom here, I'm going to have silver bromide precipitate. And so basically what's going to happen when I hit this point is it's going to be saturated in both. Because that's the right concentration to saturate it with a chloride ion concentration of 0.0500 molar. And therefore, I need to stop here because if I continue to increase the silver ion concentration, then what happens is both chloride and bromide precipitate. Okay, this is called a fractional separation because we want to separate the chloride from the bromide. And the way we're going to separate the chloride from the bromide is we're going to precipitate out the bromide and leave the chloride in solution. So I have to stop here. If I stop here, how much bromide was precipitated, or how much of the bromide was precipitated? So we have to figure out how much bromide precipitated here. So to calculate that, we have to figure out how much bromide can exist at this higher silver concentration. And so let's go ahead and do that. At this higher silver ion concentration, how much bromide in solution can exist? And so the KSP is going to dictate that because the KSP is going to equal the silver ion concentration times the bromide ion concentration. So all we've been doing is we've been increasing the silver and decreasing the bromide, getting it to precipitate out, right? And so what we're going to do now is we're going to figure out what the bromide ion concentration is at this point in this titration because a lot of it must have precipitated out. And so the bromide concentration at this point is equal to the KSP divided by the silver ion concentration. And the silver ion concentration is going to be 3.6 times 10 to the minus 9. And so what does that mean the bromide concentration is? So this is going to be 5.0 times 10 to the minus 13 divided by 3.6 times 10 to the minus 9. .38 times 10 to the negative 4 molar. And so originally we started at 0.250 molar, right? This is 0.250, and then we increased the silver until we got to that silver, and the bromide decreased until it's there. We can't decrease this anymore unless we add more silver, but we don't want to add more silver because chloride will precipitate, and we'll get two precipitations, and it won't be a clean separation. But in order to be a clean separation, the bromide is going to be pure because it's going to be silver bromide, But we're going to have a mixture left because in the beaker, in solution, we are going to have both chloride and bromide. And so what we want to know is how much bromide were we able to precipitate? And so we want to be able to figure out what was the percent precipitation of bromide. All right, so what we know is, okay, now the silver ion concentration is saturated. Silver bromide. The silver ion concentration is 3.6 times 10 to the minus 9. The bromide concentration is going to be 1.38 times 10 to the minus 4. And the chloride concentration was the same as before, 0.0500 molar. We leave all of it in there. And so the question is, what was the percent precipitation of bromide? And so why don't you try to calculate this, but it's going to be the convoluted way. We have to figure out what the percent remaining is, and then from that we'll get the percent precipitation. And so give that a shot. I'll be okay.
I just thought that time before, I was like, it's not a lot. It's less than capacity, and it's a lot. Okay, I was kind of it was really fun, tiring, but food was okay. It depends on what you like, but we ate a lot of like buffet kind of stuff. So we ate at the college, the dining hall, and the hotels are nice.